and good day to all of you. So in this part of the lecture, we are going to learn about the supervised machine learning algorithms, in which we are focusing on the classification. Inside classification, we have logistic regression and what it is, and we will learn about how it is effective for machine learning, and in which we will look at subcategories of the logistic regressions, which is sigmoid and softmax function. So let's recall the main classification of the supervised machine learning. So we have explained about the regressions, in which we have 10 types of regression algorithms. So now we are moving to the classification. In classification, we will be talking about the logistic regression and further sigmoid and softmax function. So let's start with the logistic regression. So what is logistic regression? So logistic regression is a supervised machine learning algorithms which is used for classification tasks, where the goal of machine learning is to predict the probability that an instance belongs to a given class or not. I mean, you must have to say like either yes or no. So then you have the regression analysis, the logistic regression. And it is a statistical algorithms that analyze the relationship between two data factors. So the most common logistic regression model is a binary outcome, such as yes or no, 0 or 1, or something that can take two values, such as true, false, yes, no, and so on. So in this example, we are looking at the user age, the user income, and the user gender. So either we need some of the output in which you need to say that either the age has a certain limit, so in that it will talk about either this is correct or this is correct and this is correct, then it goes to yes. Or either we will put some different classification of the logistic regression, that based on that it will say no. So I mean the last output of the logistic regression is yes or no based on the different input data. How does the logistic regression work? So the logistic regression models transform the linear regression functions that we have learned in the previous lecture, continuous values output into the categorical values output using the sigmoid function. So there is different type of function which we have. So the special task of the logistic regression is to convert the linear regression into the categorical values such as yes or no. And based on that, it will map any real value set of independent variables into a value between 0 or 1. So in sigmoid function, normally it starts from 0 to 1. And this function is known as logistic function. So let's say we have the input features. So in this multiple features we have, it's not depending on the one or two function, but it has many independent input. And also based on that, we have the dependent variables. So in dependent variable, so it will in this dependent variable, we have the different classes such as class 1 and class 2. So class 1 belongs to 0 and class 1 belongs to 1. So either it's yes or no or yes in either way. So based on that, then we apply the multilinear functions into the input data, which is x. So in this summation start from 1 to n, wi into xi plus b. So in this, actually the weight function, weight or the coefficients as, and the b is the bias term, which is this one, is known as the intercept. So let's more understand about the logistic regression with the example. So in this example, which is shown on the right side of this slide, so the logistic regression actually predicts the output of the categorical dependent variables. So therefore, the outcome must be categorical or discrete values. And it can either be yes or no, 0 or 1, true or false, etc. But instead of giving the exact value, let's say from 0 and 1, it gives the probabilities values, which lies between 0 to 1. So when we plot the data, let's say the probability of getting promoted, and on the x-axis we have the work experience. So in this type of regression analysis, so we will have discrete values rather than the 0 or 1. But the values will be, obviously we have the threshold So in logistic regression, instead of fitting regression lines which fit as an S-shape logistic function which predicted two maximum value, which is 0 and 1. So either the logistic regression, so your data will be here. So you will have either the data above 0.5, which will consider as 1, and this is considered as 0. So in that other mean, we can have this is no and this is yes. So if the data goes up above 0.5, then we consider as a yes. So the promotion or the probability of getting promoted is more in that sense. So obviously there are different type of logistic regression. So basically there are three main type of logistic regressions. The number one type of regression is binomial regression, or also we call it binary regression. So in this type of binary regression, logistic regression, there can be only two possible types of dependent variables, such as 0 and 1, either pass or fail. Like in this case, like two categories. So if we have either yes or no, so this is called the binary logistic regression. So the second type of logistic regression is multinomial, or also it's called the nominal regression. In this regression, we have three or more possible unordered type of dependent variables, such as cat, dog, or any type of features you want to put, either it's different colors or different attributes of any data. Let's say orange, gray, and green. So these are three, it's called the nominal logistic regression. The third type of regression is ordinal. Ordinal regression is actually, it can be three or more possible order type of dependent variables, such as low, medium, or high. In this we have categories, but in this we have the different sizes, let's say low, medium, and high. So in that, obviously in low we have also subcategories, let's say it can be XL or I mean extra small or small, like that. So that is different type of logistic regression we have in our logistic regressions. So let's look at, because previously we have learned about the linear regression as well. So look at the difference between linear and logistic regression. So this is a table which explains actually the differences between the linear and logistic regression. So let's look at the first difference, in which it is linear regression is a continuous dependent variable, but the logistic regression, as we learned just now, it's a categorical dependent variable. And the another thing is, this is actually solving the regression problem, but it is logistic regression, it solves the classification problem. And also in another difference is that in this linear regression, we have the value of continuous variable, but in this we have categorical variable. So it is actually normally we have the best fit line from the data, but in this type of logistic regression, we have the S-curve. So the least square estimation in this method we use in linear regression, but in this we use maximum likelihood estimation method. Another difference, which is the output must be continuous values, but in this must be categorical value. And another difference is the linear relationship between the dependent and independent variable, but in this we don't require any linear relationship. And last but not least, the difference is this may be collinearity between the independent dependent variable, which is similar as the above point, but there should not be any collinearity between the independent and dependent variables in the logistic regression. So this is a graphical differences between linear and logistic regression. So let's say if we have the similar type of data, let's say this data is plotted here and this one is here. So y is 0, y is 1. Similarly here. So but when we talk about the linear regression, so we will just have the best or the best fit line. But in this case, we normally plot the data which is showing is the S-type curve, because we have to look at the maximum point at here, and this is the maximum point. So this is the above. So now we look at the further classification of the logistic regression. So in which first one is the sigmoid and the second one is softmax. So what is sigmoid function? Actually, it is the logistic function in linear regression and is a type of sigmoid and a class of function with the same specific properties. So if you look at mathematical function that takes a real number and maps it to a probability between 0 to 1. So the formula is given here, f of x is equal to 1 over 1 plus exponential power minus x. So over here, the sigmoid function form the S-shaped graph, which means the x, which this one approached the infinity, and the probability become 1. And also the x approaches to negative infinity, approaches become to 0. So over here you can see this is a very good example. Let's say over here you can see the data is plotted based on this, and it comes up to the S-type S shape of the sigmoid function. We have further example of this one as well. So let's look at the further understanding of the sigmoid functions for the logistic regression. So the sigmoid function is fundamental elements of the logistic regression, which allows us to map the linear combination of the input features through probabilities. And also understand the sigmoid function role in logistic regression is also very essential for grasping the inner working of this widely used machine learning algorithms. And what are the function of the logistic regression or the sigmoid logistic regression? So the first thing is it is the S-shaped curve. So the most prominent characteristics of the sigmoid function is the S-curve shape, which makes it suitable for modeling the probability of the binary, which is 0 and 1, in between 0 and 1. So the second property is the bounded output. The sigmoid function always produces the value between 0 to 1, which is the ideal for representing the probability, because in probability we looking at the 0 and 1. If it is a decimal number, then probably it has the more complications on that. So the symmetry of the data is also very good. I mean the shape of the sigmoid function. So if you look at the sigmoid function, is symmetrical from 0.5. So look at the 0.5. So this is symmetrical, goes up to here and also the here. I mean the similar shape on the above and down, 0 to towards 0 and toward 1. So the sigmoid function is differentiable, allowing for calculation of gradient necessary for the optimization algorithms like the gradient descent. So now we look at the softmax function. So the softmax function is also known as the soft argmax or the normalization exponential function, which convert a vector of k real numbers into the probability distribution of the k possible outcomes. So what is the difference in the sigmoid and the softmax function is actually it is the generalization of the logistic function to the multiple dimension. I mean, it can be used multi-logistic regressions. So this is a differentiation about the softmax function and the sigmoid function. So in sigmoid function, normally you have the two classes. So we have two output, either yes or no or 0 or 1. In softmax function, it must be greater than 2. I mean, the classes should be more than 2. So let's say the class 1, 2, 3, and so on, up to the k number of classes we have in the softmax functions. So other differences that the sigmoid function activation function finds its application in the scenario where the output of the neural network needs to be continuous. Some of the common applications include the binary classification of the logistic regression model and the hidden layer of the neural networks. But if you look at the softmax function, which is the activation function, on the other hand, it is the primary use for situation where the output of the neural network is categorical. So the area where the softmax function is found is its utility. Its use in artificial intelligence and convolution neural network, the multi-class classification methods, reinforcement learning. So these are some of the application of the softmax function. So with that's all, thank you so much. Hopefully we will continue with the other type of machine learning algorithms, which is the supervised machine learning algorithms. Okay, with that's all, thank you so much and have a good day.